Welcome back. Last time we were multiplying and dividing fractions. Today we're going to be adding and subtracting fractions. And by fractions I mean rational expressions, because they're not fractions like 2/3, they're fractions that involve x and all sorts of stuff. It's just more fun. There's more of them to love. So, our learning targets for today: I can add and subtract rational expressions. Again, that one should be pretty obvious from the title. The second one, which is less obvious, is I can simplify complex fractions. And this one, I don't know, it's kind of a weird placement being in this lesson. It actually makes more sense to be in the last lesson that we did, and we'll see why when we get there. It's actually pretty easy, though. So, adding and subtracting. The key word, if I could sum up adding and subtracting in one word, it would be common denominators. Yes, that's what I said. Common denominators, that's all we need. Then we can add and subtract, just like if we had 3/4 plus 5/4. 3/4 plus 5/4 is 8/4. So, let's look at some problems. These first couple, we're going to have common denominators, just so we can see what we're doing with them. So notice 4x minus 1, 4x minus 1. Well, we have 2x minus 3 over 4x minus 1, and 3x plus 4 over 4x minus 1. We're going to put them all over just that one denominator, 4x minus 1, and we're simply going to add them. 2x minus 3 plus 3x plus 4 over 4x minus 1. Just like when we had 3/5 or 3/4 plus 5/4, that was 3 plus 5 over 4. Same idea. At this point, it's just combining like terms. 2x plus 3x is 5x. Negative 3 plus 4 is 1. So we have 5x plus 1 over 4x minus 1. It is possible at this point that it could simplify. It's not going to happen very often with what we're doing, but again, it is possible. Looking at this, though, these are already factored and they're not the same, so it's not simplifying. Let's look at another one, a subtraction one. The subtraction one is going to be the same as the addition one, except we have to subtract. And in addition to that, we have to make sure that this subtraction sign gets distributed to everything in this numerator. So notice we have common denominators, so we could rewrite it. I put parentheses around there to remind us to distribute. Do you have to show this step? No, you could go straight to this one, where we have it distributed, and then combine like terms. 3x minus 5x is negative 2x. Negative 4 minus 3 is negative 7. So we have negative 2x minus 7 over 4x plus 5. Notice in neither of these does the denominator change. I have had people do problems like this. It's like, oh, well, the denominator just equals 0, so they get negative 2x minus 7 over 0. And they leave that as an answer. That is wrong. Don't do that. Other ways you could rewrite this negative 2, hey, they both have negative. You could factor that negative out and leave it on top. Or you could actually take that negative and bring it out to the front once it's factored out. Notice these are both plus 7, because if that negative goes up there, it's going to distribute to both of those. You could also distribute it into the denominator, but that would be just kind of weird. Generally speaking, I'd probably leave it like this. Just make sure that this negative is inside the numerator. It's connected to the 2x. It is not part of the fraction as a whole, like it is here. It's part of that 2x. So don't get sloppy with your negatives. So if we have common denominators, it's pretty easy to add and subtract fractions. The trick is, what if we don't? We have to find common denominators. And common denominators, we find what's called the least common multiple, which is abbreviated LCM. The least common multiple is something that you dealt with numbers way back in the day, and you did it to find fractions. In fact, generally speaking, when I'm telling people how to find the least common multiple, I tell them, all right, so pretend that those two things are denominators in a fraction. What would be the lowest common denominator? It's the least common multiple. It's the same thing. So how do we find a least common multiple with expressions such as x squared minus 25 and x squared plus 10x plus 25? Since, again, this is figuring out, like, if these two things were denominators, how would we figure out what the common denominator is? Our first step, we need to factor these guys. So x squared minus 25, hopefully those are starting to look a bit more familiar. That's a difference of squares. That'll be x squared plus 5 times x squared minus 5. We see difference of squares a lot, as you've probably noticed. And this guy, it factors more traditionally. What times what equals 25, but adds equal 10. That'd be 5 and 5, so we get x plus 5 times x plus 5. And so, now that we have it factored, how do we find the least common multiple? Well, the first thing we need to look at is, what do they have in common? These both have x plus 5s, so we're going to need an x plus 5 in our least common multiple. And then, once we have everything they have in common, we need everything else. So, we have the x plus 5 already. We need an x minus 5, so we get an x minus 5. Over here, we have this x plus 5. We need another x plus 5. So we get that down there. So x plus 5 times x minus 5 times x plus 5 is the least common multiple between these guys. If these two things were denominators, this would be the least common denominator. So, how do we use that? Let's look at another addition problem. Here we have 3x minus 2 over x plus 6 and 2x minus 3 over 2x minus 1. So, our denominators, we need to find least common multiples. So, first step, factor. They're already factored. Second, what do they have in common? Well, they have nothing in common. This is an x plus 6. This is a 2x minus 1. So, we need both pieces. It's like if we have 1/3 plus 2/5. Well, 3 and 5, what do they have in common? Absolutely nothing. What's their least common, or lowest common denominator? 15. We have to multiply them together. So this one over here, x plus 6, we just need to multiply 2x minus 1. And can we go around multiplying denominators by 2x minus 1 whenever we feel like it, all willy-nilly like? The answer is, of course, no, we can't. If we multiply the x plus 6 by 2x minus 1, what else do we have to do? Yeah, we have to multiply the top by 2x minus 1 as well. And over here we have a 2x minus 1. We need an x plus 6. So we can multiply that by x plus 6, but again, if we do that, we have to do the same thing to the top. We now have our common denominator, 2x minus 1 times x plus 6. And then our numerators, we're going to have to multiply this out and multiply this out, and then we're just going to add them together, combine like terms. So when we multiply those out, we're going to get 2x times 3x is 6x squared, minus 4x minus another 3x is minus 7x, and then plus 2. And over here we'll have 2x squared plus 12x minus 3x is plus 9x minus 18. And so we have it all multiplied out. And again, you can go back and do that. You should be able to distribute these pretty easily at this point. So going from this step to this step shouldn't be too tough. And we're adding. When we're adding, do these sets of parentheses do anything? No. If we're subtracting, we're going to have to remember to distribute. But with addition, it doesn't make a difference. And so we can combine our like terms. 6x squared plus 2x squared gives 8x squared. Negative 7x plus 9x is plus 2x. And 2 minus 18 is negative 16. All over x plus 6 times 2x minus 1. Is it possible that we could factor this and be able to cancel? Possible, but not likely. And when we do start factoring, we'll find that it's not going to happen. So that was addition, where we had to find common denominators. Let's do another one, a subtraction one, where we have to find common denominators. So we have 2x plus 8 over x squared minus 16 minus 3 over x minus 4. First step is to factor. X squared minus 16 is x plus 4 times x minus 4. Hey, look, x minus 4, x minus 4. These are really close, except what else does this need? Yeah, it still needs x plus 4. It's kind of like when we have 3 and 6 as common denominators. A 6 is just a 2 times 3, so 3 just needs an extra 2. So, the x minus 4, we have to have an x plus 4 to go along with that. And if we multiply this by x plus 4, we have to multiply the numerator by x plus 4 as well. Our denominator now, x plus 4 times x minus 4, we can distribute the 3x plus 12, but keep in mind it's subtraction, so we're going to have to distribute that. And so when we do, we get 2x minus 3x is negative x, 8 minus 12 is negative 4. Now when we look at this negative x minus 4, that looks a lot like our denominators. I bet it's possible that we could simplify this. First, we need to factor out that negative, kind of like what we did right up here. If we factor out that negative, we'll end up with an x plus 4, which means we can cancel that, and we have negative 1 over x minus 4 as our simplified fraction. Now this one, we could have actually done a little bit easier if we saw it, and some of you may have seen it, and so we'll take a look at what this slightly easier method was. Way back up here, when we were factoring, what if we factored the top as well? Took out a 2, leaving us with x plus 4. Hey, this is a fraction that we can simplify that. That leaves us with 2 over x minus 4 minus 3 over x minus 4. Well, if we have 2 over something minus 3 over something, that just gives us negative 1 over that same something. And so that was a few less steps if you saw it, but if you didn't, this way can still get you to the exact same place. So adding and subtracting, we need common denominators. We find them with least common multiples. And then once we have common denominator, we just add the numerators or subtract the numerators, remembering to distribute the subtraction sign. Being that I've mentioned that several times, what do you think the biggest mistake is in these? Yeah, subtracting or not distributing the subtraction sign. All right, so that's adding and subtracting. This is the big piece of what we're doing today. The other piece is simplifying complex fractions. So a complex fraction looks kind of like this. It's a fraction and a fraction and a fraction. There's a whole lot of fractions going on. Really, this is two fractions inside of a bigger fraction. We can extend that middle fraction bar to kind of see that. We have 2x minus 3 over x minus 2 over 4x minus 3 over x squared minus 4. Well, this fraction is just division. That's all it is. We could rewrite this as 2x minus 3 over x minus 2 divided by 4x minus 3 over x squared minus 4. These mean the same thing. And that's why I think that this topic really should have been in yesterday's topic when we were working on multiplying and dividing fractions. But for whatever reason, it's here. But that's okay because we already know how to do this. To divide fractions, we're going to flip the second one and multiply. To multiply, we need to factor. It's all factored except for this x squared minus 4, so we can factor that. The multiplication step, just draw the line. And now what can we cancel? Hey, we have x minus 2's to cancel. And that's it. So we're left with 2x minus 3 times x plus 2 over 4x minus 3. And that's it. And this is another one where it would say that the expression is defined. If we had to worry about zeros in the denominator here, let's see, the x minus 2 couldn't equal 0, the x squared minus 4 couldn't equal 0, the 4x minus 3 couldn't equal 0 because that would make this fraction 0. as well as this fraction 0. And so there's lots of things that could happen. So we don't need to worry about that in these. With the addition or subtraction, sometimes it'll ask you to identify where it doesn't exist. Sometimes it won't. It's just where is the denominator equal to 0? Same thing as yesterday. And other than that, don't forget to post a comment, and I will see you in class.